Hey, welcome to Cat Academy. My name is Akil Smith, and in this video, I will show you how to implement a D flip-flop using the software application logisim. What is a flip-flop? A flip-flop is the simplest form of a sequential circuit. The flip-flop is a bistable device that can exist in one of two states. The flip-flop has two outputs, which are always the complements of each other. These are normally labeled as Q and not Q. Welcome to logisim. Logisim is divided into three parts: the canvas, the attribute table, and the explorer pane. Above those we have our menu bar and our toolbar. In a previous video, my colleague Asha went through the corner mapping for the D flip-flop inputs, DA, DB, and DC, where she got Boolean equations for each input. We are going to use those same equations to build our D flip-flop. These equations can be seen in the top right hand corner on the canvas. Before we can get started, please note that my colleague here used Q2, Q1, and Q0 when doing the state tables. I'm going to use A to represent Q2, B to represent Q1, and C to represent Q0. This can be seen in the bottom left hand corner on the canvas. Now let's begin to build our flip-flop. First, we'll need 3 D flip-flops. So we'll go across to our Explorer pane, click on the memory folder, look for D flip-flop, and drag it onto the canvas. We'll do that 3 times. Now we're going to label each flip-flop. We'll click on the first flip-flop, then go to the attribute table, and in the text field for the label, we'll type A. Click on the second flip-flop, and in the text field for our label, we'll type B, and for the final one, we'll type C. Now, let's label the outputs of the flip-flop. So we'll go to our toolbar, click on the text tool A, and click where we want our label to be placed. So the first output for A, flip-flop A, would be A, and the second would be the complement of A, which is not A. So for here it would be B, then the complement for that would be not B. And here for would be C, and the complement for that would be not C. Now, from our Explorer pane, we'll go to the wiring folder, click on it, look for clock, and drag it onto our canvas. Note the clock sends out a signal that changes the state of memory. Now I'm going to connect the clock to our flip-flops. Also from our Explorer pane, we're going to click on the input and output folder and get 3 LEDs. We're going to drag those onto our canvas and connect them to the first output state for each flip-flop on the canvas. The LEDs will signal which state is on. Now let's finish build our circuit using the Boolean equations for each input, DA, DB, and DC. Please note the algebraic function for the AND gate and OR gate, which can be seen in the top right hand corner on the canvas, and we'll use those to help us finish build our circuit. So let's start with DA. DA is equals to BC plus A not B. This can be read as D is equals to B and C are A and not B. So to do this, we'll need two AND gates and one OR gate. Now, I'm going to change the number of input on all my gates to 2. Let's begin with BC. So we're going to look for B. B is here. And draw a wire to the first AND gate. Next, we're going to look for C and draw a wire to that same AND gate. Then we're going to connect it to our OR gate. Now, let's do A and not B. We're going to look for A and draw a wire from A to the second AND gate. We're going to look for not B and draw a wire from not B to that same AND gate. Now we're going to connect that AND gate to our OR gate. So now we have B and C are A and not B. Now we're going to connect our OR gate to our A flip-flop. Now let's do DB. DB is equals to A, B, C plus not A, not B plus not B, not C. This can be read as DB equals A and B and C plus, R, not A and not B, R, not B and not C. So for this we'll need 3 AND gates and 1 OR gate. Just a note, to get the gates, you either go to your toolbar and click on the gate and then place it on the canvas, or go to your Explorer pane, click on gates, and then drag the gate that you need onto the canvas. So back to DB. So the first thing is A and B and C. So we look for the A, and then we're going to drag that wire to our first AND gate. But first, I'm going to change the number of inputs on this AND gate to 3, since there are 3 inputs going into this AND gate, A, B, and C. Just to add a side note, to change the number of inputs on any gate, you click on that gate and then you go to the attribute table and just look for number of inputs, hit the field drop down box, and then select the number of inputs you want for that particular gate. Next, we'll look for B and then connect it to that same AND gate. Then C, then we'll drag our wire from C and connect it to that same AND gate. So we already have a wire here, so we just drag from here and connect it to our AND gate. So here we have A, B, and C. Next is not A and not B. So we'll go look. We change the number of inputs on the gate to 2. Now we're going to look for not A and connect it to our AND gate. Next, we're going to look for not B and connect that to our AND gate. Finally, for our DB, we have not B and not C. So I'll just change the number of inputs and then look for B, connect B, not B, look for not B and connect not B, and look for not C and connect not C. Now I'm going to add my OR gate and then connect each AND gate to the OR gate. Now we have DB. Last but not least, we have to do DC. And DC is equals to A not B not C plus not A C plus not A B. This can be read as DC is equal to A and not B and not C, or not A and C, or not A and B. So we're going to need 3 AND gates. Now I'm going to change the number of inputs on each AND gate. First, we're going to do A and not B and not C. So we're going to look for A, look for the A wire, and we can continue it from here and connect it to our AND gate. Next, we're going to look for not B wire, not B's wire. Continue it from here and connect it to the AND gate. Lastly, we look for not C's wire and connect it to our AND gate. Next, we have not A and C. So we look for not A's wire, and we can continue it from here, connect it to our AND gate. Then we look for our C's wire, then we can connect that to our AND gate as well. Finally, we have not A and B. So again, we look for our not A wire, and connect it to our AND gate. Then we look for B's wire and connect it to our AND gate. Now we're going to add the OR gate to our canvas and then connect each AND gate to that OR gate. Now we are going to connect that OR gate to our flip-flop. Now, to test our circuit and to see how it works, we will hit Ctrl K on our keyboard. I hope you enjoy. Thanks for coming.